The desert stretched endlessly in every direction, a vast ocean of sand and silence, broken only by the low moan of wind, sweeping across the barren terrain of southern Iraq. Beneath the haze of dust that clung to the horizon like a permanent scar, something massive was taking shape. According to intelligence reports gathered in the weeks leading up to the ground offensive, Iraqi commanders had made a decision that would define the fate of thousands of their soldiers. They positioned roughly 300 T-55 tanks along the enormous sand berm that stretched across the southern border, a defensive line meant to serve as an impenetrable wall against any coalition advance. The berm itself rose several meters high in places, reinforced with trenches, minefields, and obstacles designed to slow any armored assault to a crawl. Behind it, the T-55s sat in hull-down positions, their turrets barely visible above the ridgeline, waiting for an enemy that Iraqi command believed would have to fight on their terms. It was a strategy born from conventional thinking, from the belief that numbers and fortification could compensate for technological disadvantage. That belief was about to be shattered in ways that would reshape modern armored warfare forever. The T-55 was a relic of Soviet engineering, a tank designed in the late 1940s and mass-produced throughout the Cold War era. By the time coalition forces rolled into the theater of operations, the T-55 had already served in conflicts spanning decades, from the plains of Eastern Europe to the jungles of Southeast Asia and the deserts of the Middle East. Its 100mm rifled gun had once been considered formidable, capable of penetrating the armor of most Western tanks fielded during the 1960s and 70s. But by the early 1990s, the world had moved on. The T-55's armor, a combination of rolled homogeneous steel measuring roughly 200mm at its thickest point on the turret front, offered protection that was essentially obsolete against modern kinetic energy penetrators and shaped charge warheads. According to technical assessments, the tank lacked a modern fire control system, had no thermal imaging capability, and relied on optical sights that were rendered virtually useless in conditions of reduced visibility. Its crew of 4 operated in cramped conditions with minimal ergonomic consideration, and the ammunition storage arrangement meant that a single penetrating hit could ignite the propellant charges stored inside the hull, leading to catastrophic detonation. Despite these limitations, Iraqi commanders deployed these machines in massive numbers, banking on the theory that volume of fire and entrenched positioning would offset individual vulnerability. Reports from captured Iraqi officers later revealed that many crew members were poorly trained conscripts who had received minimal gunnery instruction and had never fired their main guns in realistic combat conditions. On the other side of the battlefield, the M1A1 Abrams represented a quantum leap in armored warfare technology. Weighing approximately 62 metric tons in its combat-loaded configuration, the Abrams was powered by a Honeywell AGT 1500 gas turbine engine, producing 1,500 horsepower, giving the massive vehicle a top road speed exceeding 67 kilometers per hour and remarkable cross-country mobility, even in soft desert sand. But the true revolution was not in its mobility or its Chobham composite armor, which incorporated layers of ceramic, steel, and other classified materials capable of defeating most anti-tank weapons in the Iraqi arsenal. The revolution was in the eyes of the machine. The Abrams was equipped with a thermal imaging system that allowed its gunner and commander to detect heat signatures at extraordinary ranges, regardless of visibility conditions. According to documented accounts from crews who participated in the ground campaign, the thermal sights could clearly identify vehicle-sized targets at ranges exceeding 3,000 meters, even in complete darkness. Through smoke, and critically, through the dense sandstorms that would define many of the engagements in this conflict. The 120mm smoothbore gun, firing M1A1 depleted uranium sabot rounds, could penetrate well over 600mm of rolled, homogeneous steel equivalent at combat ranges, a capability that far exceeded the protection offered by any tank in the Iraqi inventory. The integration of GPS navigation into the Abrams fleet marked another decisive advantage that Iraqi planners had not anticipated. While the global positioning system had been operational for several years by the time of the ground war, Its application in ground combat operations during this conflict was among the first large-scale demonstrations of satellite-guided maneuver warfare. Tank commanders reported that GPS receivers, mounted in their vehicles or carried as handheld units, allowed them to navigate with precision through featureless desert terrain, where traditional map reading was nearly impossible. This capability meant that even when sandstorms reduced visibility to near zero, armored columns could maintain formation, follow planned routes of advance, and arrive at predetermined engagement positions with accuracy measured in meters rather than kilometers. Analysis of the campaign later confirmed that this navigation advantage was one of the most underappreciated factors in the lopsided outcomes of the armored engagements. If you are finding this story as gripping as the crews who lived through it found those desert nights, take a moment to hit that like button and subscribe to the channel. Every like and subscription helps us bring you more deeply researched stories of military history that deserve to be told. Now, back to the desert. The sandstorms that swept across southern Iraq during the ground offensive were not ordinary weather events. Meteorological reports from the period describe conditions known as shamal winds, powerful northwesterly gusts that could sustain speeds of 50 to 80 kilometers per hour for hours or even days at a stretch. These winds lifted billions of fine sand particles into the air, creating walls of brown and orange dust that reduced visibility to less than 100 meters in many areas, and sometimes to less than 10. The sand penetrated everything. It clogged air filters, scratched optical lenses, jammed mechanical components, and turned the interior of every vehicle into a gritty, suffocating environment. For the Iraqi tank crews sitting in their T-55s along the Berm, the sandstorms should have been an advantage. Conventional military wisdom held that reduced visibility leveled the playing field, negating the superior optics and range of Western tanks and forcing engagements into the close-range knife fight, where numbers might matter more than technology. This assumption proved to be catastrophically wrong. When coalition armored units began their advance toward the Iraqi defensive positions, they moved with a confidence that seemed almost surreal given the conditions. Documented accounts describe columns of Abrams tanks rolling through the sandstorm at speeds that would have been aggressive, even in clear weather, their crews navigating entirely by GPS and thermal imaging. The thermal sights cut through the suspended sand particles as if they were not there. While the sand reduced optical visibility to almost nothing, the infrared spectrum told a different story. The T-55s, their engines running to maintain readiness, radiated heat signatures that stood out like beacons against the cooler desert background. According to after-action reports, Abrams gunners began identifying Iraqi tanks at ranges of 3,000 meters and beyond, acquiring targets that had no idea they were being observed. The Iraqi crews, peering through their optical sights into a wall of swirling sand, could see nothing. They were, in the most literal sense, fighting blind against an enemy that could see everything. The engagements that followed were described by participating crews as methodical rather than chaotic. Analysis of multiple documented encounters along the Berm revealed a pattern that repeated itself across the front. Abrams tanks would advance to within firing range, typically between 2,500 and 3,800 meters, identify clusters of Iraqi armor through thermal imaging, and begin systematic destruction of the enemy vehicles. The M1A1 sabot round, traveling at approximately 1,700 meters per second, covered the distance to target in roughly 2 seconds. At these ranges, the depleted uranium penetrator struck the T-55's armor with devastating effect. Reports consistently described the results in similar terms. The sabot round would penetrate the turret or hull front of the T-55 with ease. The kinetic energy and pyrophoric properties of the depleted uranium, creating an interior conflagration that detonated the stored ammunition. Crews reported seeing turrets launched completely off their hulls, tumbling through the air, trailing fire and smoke, before crashing back into the sand dozens of meters away. The catastrophic kill mechanism was so consistent that analysts later used it as a diagnostic indicator when surveying the battlefield, noting that the pattern of turret separation was virtually identical across hundreds of destroyed T-55s. What made these engagements particularly one-sided was the complete inability of the Iraqi forces to respond effectively. The T-55's 100mm gun had an effective range against armored targets of approximately 1,500 to 1,800 meters under ideal conditions, meaning clear visibility, a stationary target, and a well-trained crew with a properly calibrated fire control system. In the sandstorm conditions that prevailed during many of these engagements, none of those conditions existed. Iraqi crews could not see their targets, could not estimate range, and could not lay their guns with any accuracy. According to analysis of the engagements, some Iraqi tanks did fire their main guns during the attacks, but the rounds were directed blindly into the storm, impacting harmlessly in the sand hundreds of meters from the nearest coalition vehicle. Other Iraqi crews, unable to identify the source of the devastating fire that was destroying the tanks around them, attempted to traverse their turrets in search of muzzle flashes, but the combination of sandstorm and distance meant that even the Abrams' main gun reports were swallowed by the wind and dust before they could be localized. The psychological impact on the surviving Iraqi crews was profound. Captured soldiers later described the experience as being attacked by an invisible enemy, a force that struck with lethal precision from beyond the veil of the storm, while remaining completely unseen and untouchable. The tactical geometry of the engagements along the Berm amplified the already overwhelming technological advantage. The Iraqi T-55s were positioned in static, hull-down positions along a linear defensive feature, a disposition that in previous wars might have provided excellent defensive value. Against an enemy with thermal imaging and precision gunnery at extreme range, however, the static positioning became a death trap. The tanks could not maneuver without abandoning their prepared positions and the minimal protection offered by the Berm. Moving across open desert in a sandstorm without GPS navigation would have been an invitation to confusion and fratricide. So the Iraqi crews stayed in place, and the Abrams gunners systematically worked their way along the defensive line, engaging one target after another with the cold efficiency of a shooting gallery. After-action analysis documented instances where individual Abrams tanks destroyed multiple T-55s in rapid succession, the gunner acquiring a new target, the commander confirming, the loader slamming another sabot round into the breach, and the gun firing again within seconds. The rate of destruction was so rapid in some sectors that entire company-sized Iraqi positions were eliminated before the surviving crews could even determine the direction from which the fire was coming. The logistical and maintenance challenges posed by the sandstorm conditions affected both sides, but the disparity in how each force coped with those challenges further widened the gap. The Abrams AGT 1500 gas turbine engine, while notoriously fuel-hungry, proved remarkably tolerant of the fine desert sand that clogged the diesel engines of many other vehicles. The turbine's air filtration system, designed with desert operations in mind, allowed the Abrams to maintain operational readiness even when the air was thick with particulate matter. The T-55's diesel engine, by contrast, relied on a filtration system that struggled with the extreme conditions. Reports indicated that many Iraqi tanks experienced engine failures or reduced performance due to sand ingestion, further limiting their already constrained ability to maneuver or reposition. The thermal imaging system of the Abrams also proved more resilient than some had expected, the cooled infrared detector maintaining its sensitivity despite the environmental conditions. Crews reported that while the sandstorm degraded their thermal picture somewhat compared to clear conditions, the system still provided more than adequate target detection capability at the ranges at which engagements were occurring. The role of combined arms coordination in the coalition advance deserves particular attention, as the destruction of the Iraqi armor along the Berm was not solely the work of the Abrams tanks operating in isolation. Artillery units, guided by forward observers equipped with GPS and laser designators, delivered preparatory fires on known and suspected Iraqi positions before the armored advance reached engagement range. These fires served multiple purposes. They disrupted Iraqi command and communication networks, forced crews to button up inside their vehicles where their already limited situational awareness was further reduced, and in some cases, destroyed or damaged tanks and fighting positions before the Abrams even arrived. Attack helicopters, when weather conditions permitted their operation, added another layer of firepower, engaging Iraqi armor with Hellfire missiles from standoff ranges that the T-55's anti-aircraft machine guns could not reach. The integration of these capabilities created a layered kill zone that the Iraqi defensive positions were simply not designed to withstand. According to analysts who studied the campaign, the synergy between these systems multiplied their individual effectiveness, creating a combined arms effect that was greater than the sum of its parts. The human dimension of these engagements, while often overshadowed by the technological narrative, was no less significant. Inside the Abrams, crews operated under enormous physical and psychological stress, despite their overwhelming tactical advantage. The interior of the tank during a sandstorm was a challenging environment. The constant vibration of the turbine engine, the confined space, the heat that built up inside the vehicle despite the climate control system, and the ever-present grit of sand that worked its way through every seal and opening. Crews reported that maintaining focus during extended engagements required disciplined rotation between the commander's and gunner's positions to prevent fatigue-induced errors. The responsibility of knowing that each trigger pull meant the death of 4 men in a distant tank weighed on many crew members, a psychological burden that some described only years after the conflict. For the Iraqi tank crews, the experience was incomparably worse. Trapped in vehicles they knew were outmatched, unable to see the enemy that was methodically destroying their comrades, many faced an impossible choice between remaining in a vehicle that had become a coffin or abandoning it to flee across open desert under fire. Captured Iraqi soldiers described the terror of hearing the supersonic crack of sabot rounds passing nearby, the thunderous detonations as neighboring tanks were hit, and the desperate radio calls from other crews pleading for information about the enemy's location, calls that went unanswered, because no one could see anything through the storm. The aftermath of the engagements along the Berm presented a scene of destruction that shocked even the most hardened military professionals. When the sandstorms cleared and the dust settled, the defensive line was revealed as a graveyard of burned and shattered armor. Survey teams documented hundreds of destroyed T-55s stretched along the Berm, many with their turrets blown off and lying inverted in the sand beside their hulls. The ground around each destroyed vehicle was blackened by fire and littered with debris, ammunition fragments, and the remnants of equipment that had been ejected by internal explosions. According to reports from teams that surveyed the battlefield, the pattern of destruction was remarkably consistent, indicating the systematic nature of the coalition's engagement methodology. Many of the destroyed tanks showed single penetration holes, evidence that the accuracy of the Abrams fire control system was so high that multiple rounds per target were rarely necessary. In some areas, the density of destroyed vehicles was so great that they formed nearly continuous lines of wreckage along the Berm, a testament to both the number of tanks the Iraqis had deployed and the thoroughness with which they had been eliminated. The strategic implications of these engagements extended far beyond the immediate battlefield. Military analysts around the world studied the results with intense interest, recognizing that the desert had provided a stark demonstration of how thermal imaging, GPS navigation, and depleted uranium ammunition had fundamentally altered the dynamics of armored warfare. The traditional calculus of tank versus tank combat, which had always emphasized factors like armor protection, gun caliber, and crew training, now had to account for the revolutionary impact of the ability to see and navigate in conditions of zero visibility. Armies that had relied on large fleets of older Soviet-era tanks as the backbone of their armored forces were forced to confront the uncomfortable reality that quantity no longer compensated for quality in the way it once had. According to defense analysts who published assessments in the years following the conflict, several nations accelerated programs to acquire thermal imaging systems and modern fire control technology for their armored vehicles, recognizing that without these capabilities, their tank forces were essentially obsolete on the modern battlefield. The engagement ranges documented during the sandstorm battles particularly captured the attention of military professionals. Confirmed engagements at 3,800 meters in conditions of near-zero optical visibility represented a capability that many pre-war assessments had considered theoretical rather than practical. The The combination of thermal imaging for target detection, laser rangefinding for precise distance measurement, and a computerized fire control system that automatically calculated ballistic solutions accounting for factors including crosswind, ambient temperature, barrel wear, and ammunition type meant that the Abrams could achieve first-round hit probabilities at extreme range that previous generations of tanks could not match even at point-blank distance. Analysis revealed that the effective engagement envelope of the Abrams was approximately twice that of the T-55 under ideal conditions and in reduced visibility conditions. The disparity grew to the point where the T-55 essentially had no effective engagement capability at all, while the Abrams retained nearly full lethality. This asymmetry in effective range created a situation that military theorists described as a no-contest zone, a band of distance within which one side could kill with impunity, while the other could not even detect, let alone engage, its attacker. The lessons regarding GPS-guided maneuver warfare were equally profound. The ability of coalition armored formations to maintain cohesion, navigate complex routes, and arrive at planned positions with precision during conditions that would have caused previous armies to halt and wait for clear weather represented a paradigm shift in ground operations. Commanders who participated in the advance reported that GPS navigation gave them a level of confidence in their positional awareness that fundamentally changed how they made tactical decisions. Rather than being constrained by weather and visibility, to operate only when they could see terrain features and maintain visual contact between vehicles, they could plan and execute maneuvers based on precise coordinates, arriving at engagement positions calculated to maximize their advantages in range and terrain. This capability turned the Sandstorm from a hindrance into an asset, a cloak that concealed their advance from an enemy that lacked the technology to penetrate it while doing nothing to impede their own operations. Analysis later confirmed that some of the most successful engagements occurred during the worst weather conditions, precisely because the environmental degradation of visibility affected only the Iraqi side of the equation. The contrast between the two armored forces also highlighted important lessons about crew training and doctrine. Coalition tank crews had undergone extensive training in gunnery, navigation, and combined arms operations at facilities designed to replicate desert conditions. They had practiced engaging targets at extreme ranges using their thermal sights, conducted movement exercises using GPS navigation, and rehearsed the coordination between tanks, artillery, and aviation that would prove so devastating in combat. The Iraqi tank crews, by contrast, had received training that was adequate for operating their vehicles in a basic sense, but that did not prepare them for the specific challenges they would face. According to captured documents and debriefings, Iraqi armored doctrine emphasized the defensive battle from prepared positions, with the expectation that enemy forces would advance into engagement ranges where the T-55's gun would be effective. The doctrine did not account for an enemy that could engage accurately from well beyond the T-55's effective range, and it did not provide procedures for dealing with an opponent that could see through conditions of zero visibility. This doctrinal gap meant that even well-motivated Iraqi crews were fighting according to a playbook that had been rendered irrelevant by the technology arrayed against them. The maintenance of the T-55 fleet also contributed to the lopsided outcomes in ways that are sometimes overlooked in analyses focused purely on the engagement dynamics. Many of the Iraqi T-55s had been in service for decades, with maintenance histories that reflected the challenges of operating complex mechanical systems in a resource-constrained environment, subject to international sanctions. Reports from post-battle technical examinations of captured and destroyed vehicles indicated that many tanks showed evidence of deferred maintenance, improvised repairs, and the use of non-standard parts and lubricants. Gun barrels were worn beyond specification, reducing accuracy. Optical sights were scratched, fogged, or misaligned. Engine performance was degraded by years of operation in dusty conditions, without adequate filter replacement. Ammunition stocks included rounds of varying age and condition, some dating back decades, with uncertain reliability and performance characteristics. While these factors might have been manageable in a conflict against a similarly equipped adversary, they compounded the already decisive disadvantage the T-55 faced against the Abrams, turning a difficult situation into an impossible one. The psychological dimension of the defeat reverberated through the Iraqi military in ways that extended far beyond the immediate tactical impact. Surviving crews who escaped the destruction along the Berm carried with them stories of an enemy that could not be seen, could not be fought, and could not be stopped. These accounts spread through the remaining Iraqi formations with devastating effect on morale. According to intelligence reports, some Iraqi units that had been positioned as second-echelon reinforcements abandoned their vehicles and retreated before coalition forces even reached their positions. The psychological impact of the reports from the front line proving more destructive than any physical attack. The combination of technological dominance and the terrifying manner in which it was demonstrated, the invisible strikes from beyond the sandstorm, the instantaneous destruction of vehicles that the crews had believed were safely concealed, created a crisis of confidence that undermined the will to resist across significant portions of the Iraqi military. Analysts noted that this psychological effect multiplied the tactical impact of the actual engagements many times over, as entire units were rendered combat ineffective, not by direct fire, but by the knowledge of what awaited them if they stood and fought. The legacy of the engagements along the Berm continues to influence military thinking and armored vehicle design decades later. The demonstration that thermal imaging could transform a sandstorm from an obstacle into an advantage drove massive investment in infrared technology for military vehicles worldwide. The effectiveness of GPS-guided maneuver warfare in the featureless desert validated concepts of network-centric warfare that would shape military doctrine for the following generation. The devastating performance of depleted uranium ammunition against Soviet-era armor prompted both offensive and defensive responses, with nations developing new armor compositions intended to defeat kinetic energy penetrators, while others pursued advanced ammunition designs to maintain the advantage. According to contemporary defense analysts, the technological lessons of those engagements remain relevant, even as new systems like active protection suites, unmanned platforms, and artificial intelligence begin to reshape the armored battlefield once again. Perhaps the most enduring lesson of the 300 T-55s along the Berm is the most fundamental one. Technology alone did not win those engagements. It was the integration of technology with training, doctrine, logistics, and leadership that created the overwhelming advantage coalition forces enjoyed. The thermal sights were useless without gunners trained to interpret their imagery and engage targets at extreme range. The GPS navigation was meaningless without commanders who understood how to use precise positioning to create tactical advantage. The devastating ammunition was wasted without a fire control system that could place it on target and loaders who could sustain the rate of fire needed to exploit the fleeting opportunities of combat. The destruction along the Berm was not simply a triumph of expensive equipment over obsolete machinery. It was a demonstration of what happens when every element of a military system, from the individual crew member to the satellite orbiting overhead, works in concert toward a common objective, and when the opposing force lacks even one of those critical elements. The sand eventually buried the wreckage, as it buries everything in that ancient landscape. But the lessons written in fire and steel along that Berm endure in every armored force that studies what happened there. A reminder that in modern warfare, the side that sees first, shoots first, and moves with precision will prevail, and the side that cannot do these things will cease to exist as a fighting force with a swiftness that defies comprehension. The desert is quiet now, where the Berm once stood. The wind still blows, the sand still shifts, and the Shamal storms still sweep across the flat terrain with the same fury they have shown for millennia. Somewhere beneath the dunes, the rusted hulks of T-55s slowly dissolve, their steel returning grain by grain to the earth from which it was once smelted. They are monuments to a moment when the nature of armored warfare changed forever, when 300 tanks positioned with confidence along a defensive line discovered that the rules they had been built to fight by no longer applied. And somewhere in motor pools and training grounds around the world, the descendants of the machines that destroyed them continue to evolve, their sensors sharper, their ammunition more lethal, their navigation more precise, each improvement building on the lessons that were first written in the burning wreckage along the Berm, on those sand-choked days when the storm itself became a weapon for those who could see through it.